In this video, we're going to be going over Gaussian elimination using row operations. So as you know, if you're giving a three variable systems of equation, you were trying to solve for three specific values, x, y, and z. It would be very complicated to use substitution and elimination, so turning it into a matrix and performing row operations is a standard procedure in solving for your systems of equations where three planes intersect. So take for example, I have a systems of equation 3x minus y plus z is equal to -1. 2x plus 3y plus z is equal to 4, and 5x plus 4y plus 2z is equal to 5. So we're going to perform Gaussian elimination and row operations, but my first thing is I need to turn it into an augmented matrix. So recall that an augmented matrix is written in, we're just looking at the coefficients of our variables. And we're also looking at the constants outside of, on the other side of the elimination, of the equal sign. So I'm going to build my matrix. And I'm going to start with filling in values, starting with my x's. So I have 3, 2, and 5. For my y's, I have -1, 3, and 4. For my z's, I have +1, +1, and 2. And then, for my equal sign, I replace that with a long line down the middle. And for my constants, I just write them as they are. So take a notice at my matrix, okay? So with matrices, they're written into rows and columns, where your rows, so this would be your row 1, your row 2, and your row 3 are viewed from top to bottom in order. Then you have your columns, okay? So this column represents your x values. This column represents your y values. And this column represents your z values. So this is what the matrix we will be performing row operations will be on. Our goal now is to try to turn my augmented matrix into a row echelon form where I have ones on my diagonal, zeros below them, and any values above it. And we're going to do that using row operations. So typically your first goal is to try and turn your first entry, which is your first row and first column entry value, my 3, and I want to try and turn it into a 1. So there are multiple ways you can go about it, such as dividing row 1 by 3, but that would give you fractions, which can get messy very quickly. But one thing we can do is we can go ahead and use row 2 to help us manipulate row 1. And an easy way we could do this is, how do I use 3 and 2 to turn it into 1? Well, I can subtract 2 from 3, so I can do row 1 minus row 2. So writing that down, you have, so my new row 1 will have row 2 subtracted from row 1. When we turn that, so my new row 1 will be 3 minus 2, which gives me 1, negative 1 minus 3, which gives me negative 4, 1 minus 1, which gives me 0, and negative 1 minus 4, which gives me negative 5. This is now my new row 1. After calculating my new row 1, I can now try and manipulate my second row. I want to turn this 2 into a 0 and this 3 into a 1. But typically, I would recommend sticking with one column at a time, getting 1 in your first row and getting zeros below it. So I need to turn this 2 into a 1. Now, what would be the easiest way to do that? I would recommend using row 1 to help you turn this 2 into a 0. And one way that you can do that is you can multiply row 1 by 2 and subtract that from row 2. So we can do row 2 minus 2 row 1. When we do that, we start with 2 and we go backwards to row 1. So that is 2 minus 2 times 1, which is 0. So my second row is now 0. I now have 3 minus 2 times negative 4. I can write this out here. So 3 minus 2 times negative 4. This gives me 3 plus 8, which gives me a positive 11. I now have 1 minus 2 times 0, which is just 1. And then I have 4 minus 2 times negative 5, which is the same thing as 4 plus 10, which gives me 14. This is my new row 2. Our next goal is to now turn our 5 into a 0. We can't really use row 2 because 0 cannot really be turned into anything using the proper row operations, but we can use row 1. We can take row 3, 5, and subtract that by 5 times row 1. So that would be row 3 minus 5, row 1, in order to eliminate that 5. So let's go ahead and work each entry in row 3 together. So in this case, that is 5 minus 5 times 1. This will give me 0, which is our goal. Next, we have 4 minus 5 times negative 4. This is just 4 plus 20, which gives us 24 in our second entry. Then we have 2 minus 0 times, 2 times negative 5 2 minus 5 times 0, which gives us just 2. And then finally, 5 minus 5 times negative 5, which gives me 5 plus 25, which is just 30. This is my new row 3. Now our next goal is to try to turn my 11 into a 1 and the 24 into a 0. So I would always recommend turning your middle entry for your matrix into 1 before turning the value below it into a 0. So the way that I'm going to turn this 11 into a 1 is going to be a little off kilter. So because I have 11, 1, and 14, they don't have anything in common. They're actually very different numbers. They don't have any factors in common. 11 and 1 is prime, but 14 is not. There's really not much I can do with it. But what I can do is I'm going to multiply my row 2 by 2, and then I'm going to subtract row 3 from my row 2. So first things first, let us do 2 times row 2. So I'm going to multiply the entirety of row 2 times 2. This leaves me with 2 times 0, which is just 0, 11 times 2, which is 22, 1 times 2, which is 2, and then 14 times 2, which is 28. This is my new row 2. And you'll see why I did this in a minute. So I decided to multiply row 2 by 2 in order to get it very close to row 3 so that I can use row 3 to manipulate row 2. So to get my new row 2 entries, I'm going to do row 3 minus row 2 to get my new row 2 entry. So in this case, where my new row 2 starts with 0 minus 0, which is just 0, 24 minus 22, which is just 2, 2 minus 2, which is 0, and then 30 minus 28, which is 2, giving me my new row 2 values. So at this point, all I need to do to turn my middle entry into 1 is just divide row 2 by 2. This leaves me my new entries to be 0, 1, 0, and 1. This is my new row 2. So now that I have 1s in my first 2 rows diagonals, I can now turn this 24 into a 0 easily by using row 2. So I would do row 3 minus 24 row 2 easily. So using this, my new row 3 is going to be 0. So 0 minus 24 times 0 just gives me 0 as my first entry. For my second entry, that is 24 minus 24 times 1, which is again just 0. Then finally, I want to use 2 minus 24 times 0, which just leaves me with 2. Then I have 30 minus 24 times 1, which gives me 6. This is my new row 3. Now, at this point, all I need to do to turn this 2 into a 1 to get it in reduced echelon form is just divide all the entries in row 3 by 2. In that case, my row 3 now becomes 0, 0, 1, and 3. This is now my new row 3, and I have turned my matrix into row echelon form. At this point, now that all my entries is in row echelon form, I can now turn it back into a system of 3 equations. So in this case, starting from top to bottom, this is just x minus 4y plus 0z is equal to negative 5, y is equal to 1, and z is equal to 3. Once I've turned it back into systems of equation, I can now back substitute, also known as back sub. I know that z is equal to 3 and y is equal to 1. I can plug in what I know for y to solve for x. This leaves me with x minus 4 times 1 is equal to negative 5. This is just a regular linear equation, so that's x minus 4 is equal to negative 5. Adding 4 on both sides, I have x is equal to negative 1, making my solutions to be negative 1, 1, and positive 3. Alright, that is all for this video, and I will see you later for the next one.